Assalamu alaikum. Let's look at some Doppler effect examples. I'm going to work easy first, and then it's going to gradually get harder. Okay. So it says a siren is making a sound at a frequency of 8,500 hertz while driving down the street. It is a cold day, and the speed of sound is 300 meters per second. If the ambulance approaches you at, that should be, I don't know why it says that, it should be 35 meters per second. If the ambulance approaches you at 25 meters per second, determine the frequency that you will hear. So remember, the frequency that you will hear, okay, is the apparent frequency. So that's what we're trying to find here. The frequency that it makes, whether you hear it or not, that's the true frequency. So our frequency here, Fs, is 8,500 hertz. And the V of the sound is 300 meters per second. And your source speed is 25 meters per second. Now, it says that it's moving towards you, right? It approaches you. So, since it approaches, right, we're going to write that word, approaches. Then we're going to use the plus sign. Okay, so we're going to go F is equal to, this is what we're trying to find, V divided by our V, again, minus Vs, multiplied by the true frequency of the source. The speed of sound was 300, and that'll be divided by 300 minus the speed of the source, which is 25, multiplied by the true frequency, which is 8,500 hertz. And when you plug that into your calculator, and please don't forget to do brackets, especially when you're subbing in the speeds here. You plug that in your calculator, and you should get, if I put this into scientific notation, about 9.27 times 10 to the 3 hertz. So again, I said use the plus sign. I meant use the minus sign. If it's going towards you, you use the minus sign. Sorry about that. That confuses you. Ignore the first part of the video. We use the minus sign. All right, let's look at our second example here. Okay, so the second example reads, a burglar alarm is wailing with a frequency of 1200 hertz. So remember, that's not what's heard, that's just the natural frequency. So our F of the source is going to be 1200 hertz. And what I do is I like to write these ones right away because I find that these problems require a little bit of reading comprehension. And sometimes it's a little bit hard to decide between what's the apparent frequency and what's the true frequency. So as soon as I get a good idea, I tend to write it right away. What frequency does a cop who is driving towards the alarm? All right, so if it's towards, okay, the alarm at a speed of 40 meters per second. So if it's towards, we're going to also use the minus sign. Okay. And we have a V of the source at 40 meters per second. The speed of sound, it says here, is 352. Okay. So the speed of sound here is 352.3 meters per second. It wants to know what frequency does the cop hear? So, similar to the last example, we're trying to look for the apparent frequency. And since we know that it's moving towards, we're going to use this formula over here. And really, there's nothing to manipulate. We're just going to sub all that we have in. So this is 352.3. divided by 352.3 minus the speed of the source, which is 40.0. Okay, multiplied by 1200 hertz. Okay, again, plug this into your calculator. Make sure to be very careful while you do it. And the answer you should end up getting is about 1336 hertz. Okay, so far this should seem pretty easy. Let's go to a more challenging example. Okay, so for the last one here, a car approaching a stationary observer emits 450 hertz from its horn. If the observer detects a frequency of 470 hertz, how fast is the car moving? The speed of sound is 343 meters per second. Okay, so first we're going to write down everything that we have. We got that a car approaching a stationary observer emits 450 hertz from its horn. That's not what's actually heard. So we have our true frequency of 450 hertz. Now we're also given an apparent frequency, right? The observer detects a frequency of 470. And we're given a speed of sound, 343 meters per second. What we don't know, and what we're trying to look for, is the speed of the source. Now, we also know that it's going towards, right? Because it approaches the observer. And so we know that when it comes to our equation, we're going to use, once again, the negative sign. Okay, so the question is, how do we get this? So let's do a little bit of algebra first. Because if you don't do the algebra, it gets difficult quite fast and you're much more likely to make a mistake. So what I'm going to do here is I'm going to step-by-step isolate for this guy. So the first thing that I'm going to do, and we'll do this all in red, I'm going to divide both sides by Fs so that I can get rid of it on this side. And when I do that, I'm left with F over Fs equals V minus V minus Vs. Okay? The next step that I'm going to do here, because in math you're allowed to do this, I'm going to group this term together by putting brackets around it. Okay? And so by doing that, now my new formula is going to be F over Fs equals V bracket V minus Vs. And once I've done that, I am going to cross multiply this over here and this over here. And you'll see why, not this the next step, but the step after that, why I did that. And when I do that, I get F bracket V minus Vs equals FSV. I'm going to do some distributive property here. And that'll leave me with the following. I'm going to get F times V, so FV stuck together, minus FVS stuck together equals FSV. At this point, I'm going to try and put all like terms on the same side. And by like terms, we mean that they're similar variables. This here and this here can be considered like terms because they both have the V. And so I'm going to move this over here. And when I do that, I end up getting this formula. Minus FVS equals FSV minus FV. And then finally, to get the speed of the sound, the speed of the of the object, we're going to divide both sides by negative f, and that leaves me with this. And that's the speed of the source. Okay, so when I've subbed in everything here, I have my observer frequency, the true frequency as 450 multiplied by the speed of sound minus the observer frequency, or the apparent frequency, of 470 multiplied by 343 divided by negative 470. When you plug this into your calculator, the answer you're getting is about 14.7 meters per second, or if the question asks you to round, which in this case there is no indication, or 15 meters per second. So with this question, it's just really important to do the algebra step by step. Okay? So I urge you guys to try the worksheet out, and it will be on the next question set that you'll be answering for me, so we will talk about that more in detail. Stay tuned for the announcements. Please try the problems. All right? Assalamu alaikum, guys.